Hello and welcome to another Creative TD production. In this particular video, we are going to continue our shader development here, our surface shader, and start to use the normals that we have on our shader now. Because now that we've actually computed a per pixel normal, what we can do is we can do a whole bunch of different effects with the model itself. Like you can do specular, you can do like rim lighting, you can do like what I'm going to be showing in a few more future videos, BRDF shading. You can sample reflection maps or cube maps, as they're called in Unity. So you can actually do a lot once you have this data already computed on your shader. So let's get into it. This is going to start to dive into some more deeper concepts in shading. We are going to actually use the dot product function, all right? And I'm going to actually explain what a dot product is to you guys if you don't already know. And I have a visual example to show you just exactly what it does. Usually makes it a lot easier to understand when it's a little more visual. So, but first let's get our rim light going on our shader here, and then I'll step through it and hopefully describe how a dot product actually works, okay? So let's do that. So let's go into our shader here. And what we're going to need is a couple of properties first. All right, so we want to be able to tint our rim light with a color. So I'm going to say rim color. And we're going to call this rim color. And we're going to capitalize that. And then it's going to be of type color. And I'm just going to set it to 1 for now, or white. All right, and we're also going to need a rim power. Now the rim power is going to control how sharp or how broad the rim effect is on the surface of our model, okay? And you'll see, it'll make sense once we get the effect on there. And this is going to be a range, it's of type range, all right? Now this means that we can actually define an area of numbers that you can use a slider to pick from, all right? So that means that when we say range, we're going to actually have a slider inside of the inspector that allows us to go between 0.5 and 8 in this case. You can set these up to whatever numbers you want. All right, and we're setting it to a default value of 3. Okay, so the next piece of information that we need is the view direction. So we can actually get that from our struct. So we can say float 3 because it's a vector, right? It's a direction in 3D space, so it needs to be float 3. That's X, Y, and Z. All right, and it's going to be called view dir. All right, this will actually give us a built-in value that Unity is giving to us. Basically, the view direction is if you were to imagine, let's go back here. If you were to imagine a ray, single like arrow coming out of the middle of our screen and hitting the surface, that would be our view direction. All right, so we can actually use that view direction to create different effects. All right, and then we need to set up the link between the properties and the actual shader itself. So I need a float 4 because this is going to be the rim color. All right, so we set up that link, so now I have access to the rim color property. And then I want to do a float for the rim power because this range here is going to return a single float value, whatever we left the slider on. So let's float and call this rim power. All right. So that's all that. So now we have all the information that we actually need to produce our rim effect. These two values, the view direction, and some properties to help us modify it inside of the inspector or inside of Unity. So the last thing we need to do is actually add it to our surface shader here. All right, so I'm going to just add a little bit of space just so I know that, just to organize it code-wise, so I know that this section right here is going to do the rim. So I'm going to declare a half. All right, and that's just a smaller version of like a float, smaller version in terms of the precision values for performance reasons. All right, what I need to do is I need to do the dot product, all right, of the view direction to the normal on the actual model itself, right? So we actually have the normal per pixel on the model, all right? And we have the view direction, or the direction we are currently looking at the model in, okay? So what we want to do is we want to say dot in dot view direction, right? Because we're pulling in the view direction from our input struct, okay, which is called in, right? We store all those values inside of in. And now what we're doing is we're going to say dot in viewdir with o dot normal. All right, so now what we actually have is a value that goes from -1 to 1. All right, and this is where I'm going to actually show you. I'm going to visualize what's happening here, okay? So let's go back into Unity. Okay, I'm actually going to turn these guys off just so we don't have to worry about them for now. And I set up this prefab here. Now this prefab is set up so that we can actually see how a dot product works, okay? So dot product basically will return a float value, right, between 1 and -1, depending on the angle of two vectors, okay? So imagine this is our view direction, and imagine that this is the normal that's on the model, okay? So if I were to become more parallel with my view direction, I'm actually going to get a value of 1, all right? The more perpendicular I get to my view direction, right, I get 0. And the more in the opposite direction I am of my view direction, I get -1. And it works all the way around in a sphere. All right, so you can see how the dot product is changing as I change the angle of those two vectors. Okay, so let me just reinforce that by also drawing for you here in Photoshop. So let's say, hold on a sec. There we go. So let's say here's my camera, or here's my eye, right? Let's put some of those little guys, and I'm looking at this model in this direction. Now the model itself, the sphere that we're working on, has a whole bunch of normals on the model per pixel. Obviously, I'm not going to draw all those vectors, right? Each one of those normals is a direction in space. All right. So that means that I can actually get a value from 1 to -1 over the entire model. And I can actually use that information. So we're going to get 1, something like 0.7, 0.6, 0.5, 0.4, all the way up until we get to 0. And then this would be -1 over here. All right, so what you can actually do is you can actually tint the model using these values. All right. So hopefully that kind of clears it up for you. Basically, just remember that when you use this dot product, the return value from this is going to be a float, okay? And in this case, we're storing it in a half just for performance reasons, okay? And that value is going to change as the normal changes compared to our view direction. All right, so that's how that works. All right, so let me turn this back on here. Okay. Now we want to do a couple things before we just use this number straight up, right? The first thing that we want to do is we want to saturate that value. That way we make sure that the value is actually within that range of -1 to 1, okay? We don't want to get any more values, and that's what the saturate function will give us. It kind of normalizes it out for us. Which actually reminds me, we should also normalize the viewdir. All right, so we need to normalize. So this makes sure that I get a value of 0 to 1. There we go. All right. So now we normalize it and we saturate it. And now what we can do is we can actually just use this value straight up. So we can actually set this up to see what we're actually getting. So to set this up, what we want to do is we want to access the emissive property of our surface shader. So to do that, we say O dot emission equals our rim color dot RGB, right? We don't need the A in this case, or the alpha, times the power of rim taken to the rim powers value. All right, so we're raising the value that's coming out of rim to this power. Okay, and then we're tinting it with this color. So let's save that and make sure we didn't get any errors. And we did. So it says down here that we don't have a float arrange property, but the actual errors up here says we don't have view dir. Oh, so sometimes the errors from a shader can actually be quite cryptic. And the reason why all these guys failed is because this guy failed. And the reason why this guy failed is because view dir actually has a capital D, I believe, if we look at our code. Yeah. So view dir has a capital D in it, and I actually said view dir with a lowercase d. So if you actually look, all this doesn't really mean anything to you. It was this first error that meant something to you. That's the reason why all these other guys failed. So just change that, save it, come back in here, and we'll check out. No, we're still getting some error here. Normalize, right? Again, I always look at the top one. So in this case, it's telling me that the dot product has an error, but the second argument for the dot product is working, but the first one has an error. And then because dot product is throwing an error, saturate is throwing an error, and it's because normalize doesn't have an L in it. So I apologize, guys, but it's good to see, how people actually fix shaders when you get errors. So let's see if that worked. There you go, that worked. Let me close the console here. All right, so now you can actually see, let me clear this out. Now you can actually see that we're tinting the model based on our view direction. And we actually have, if we go to our material, we can change that tint color, right? We can also make it sharper. So you can actually tint the model based off the view direction, but this isn't what we want, right? We don't want to tint it based off of the exact point that we're looking at, right? We actually want to get a nice rim light around the whole object here. And to do that, and the reason why we're getting this is because we're getting 1 as a dot product value with the normals that are looking directly at us, and we're getting 0 for all the normals that are looking perpendicular, like completely perpendicular to us. So we're getting black here, and we're getting white here, and then we're basically just multiplying that value by this color, and that's why we're getting the effect that we're getting. Okay. So what we actually want to do is we actually want to invert this, and to invert it's really easy. All you need to do is just say 1.0 minus all of this. So we just invert it by negating it or subtracting it from 1. So let's save that. Come back here. And there you go. So now we're saying, because we inverted it, now we're saying it's 1 up here and 0 in the front. And now we have power over that fall off. Right? It's just like in Max or Maya. In Max, you have the fall off attribute for a shader, and in Maya, you have the facing ratio that you can set up. All right. So that is how you do that. And that is how you set up a rim light to control the shader. Pretty simple. You can set it up for whatever color you want. It's pretty easy to do. As we move forward in the shader series, things are going to get a little bit more complex, but I will do my best to explain the reasons why these effects happen, and do my best to explain the math behind all of it. So hopefully that helps you guys out a little bit. And again, if you have any questions, feel free to email me at kennyl@creativetd.com or visit my website at www.creativetd.com. Thanks very much.